This video is going to talk about key features of graphs. So if this is our graph over here, our function f of x, if you will, first thing we're going to talk about is x-intercepts. So x-intercepts are where this thing is going to cross the x-axis, because here's my x-axis, okay? And so I'm just picking out the points at where this thing is going to cross the x-axis. So it happens here at this first point, which is negative 4.422 comma 0. I've got another one, boom, right here at negative 1.083 comma 0. And my last one is over here at 2.505. I'm running out of room here. 2.505 comma 0. Notice that all of my y values here are 0 because it's on the x-intercept, so I have not gone up or down, so that's why I have a y value of 0. Well, if x-intercepts were across the x-axis, then y-intercepts, stands to reason, would be where this thing crosses the y-axis. And so this time I only have one of them, and it happens at the point 0 comma 4. So my y-intercepts here, there's just one of them, and it's the point 0 comma 4. Another thing we're talking about here is relative minimum and relative maximum. It's really the same concept, and our graph here is going to go on to infinity and negative infinity, depending on the direction here. So negative infinity over here, positive infinity up here. It's going to keep on going forever. And because it goes on forever in either direction here, we don't really have a minimum or a maximum. And so we call this relative minimum and relative maximum kind of the portions of the graph that we can see where there is a maximum or a minimum. And so the minimum for this graph currently kind of sits here at 1 comma negative 5.667. So the relative minimum here is really a y value, because the minimum refers to how high or low the graph is going. And so in this case, the lowest point that we can see is negative 5.667. Now, maximum is the same concept, except now we're looking for a maximum value. So it happens here at this point, and that has a y value, again, of 5. So I would have a relative maximum of 5 on this graph, and I would have a relative minimum of negative 5.667. Okay, we've got a couple few features here that we still need to talk about. We've got intervals here where this thing is positive and where it's negative, and then where it's increasing and decreasing. So let's stick to the positive first. Okay, so when I'm looking at whether this thing is positive or negative, I'm going to change colors here real quick. When I'm looking at whether this thing is positive or negative, okay, I'm looking at y values. Okay, I'm looking at y values, but I am using x value intervals. So I'll explain what I mean by that right now. Okay, so if this is my x-axis, okay, then I see that this range right here is positive. This little curly Q is above the x-axis. All of my y values are positive right here. So even though I am looking to see which y values are positive, I'm using this x value interval to explain where that happens. So my graph is positive from an x value of negative 4.422 over to an x value of negative 1.083. Okay, now as I continue on my graph, this is negative, and we'll get there in a moment. But then at this point here, it goes back positive again, and it's going to go positive forever. So this is also positive at an x value interval of 2.505 to infinity. It'll never go back negative again because it's going to keep rising and rising. Okay? Now conversely, we have an interval where it's negative. So now I'm looking on my graph at all of these values where the y values of my coordinates are negative. And so my first one happens over here, and this is going to keep going negative forever. So this happens from negative infinity as an x value up to an x value of negative 4.422. Now my graph goes back positive, and whoop, at this x value, I've got this another little curly Q, but all of these y values now are negative in this range. So from negative 1.083 to an x value over here at 2.505, this thing is negative. So we have x value intervals here for when it's negative, but I'm using the y values to determine that. Now that is altogether different than when our intervals are increasing or decreasing. And so here's what I'm doing when I look for something that is increasing. I'm starting here on my graph, and I'm just asking myself, am I traveling upward or downward? And currently I'm traveling upward. So I know that right now, everything in here is increasing, and whammo, I get to this point and then it starts to decrease. So if I'm just labeling where my interval is increasing, it stops increasing right here. So if I want to write this interval, remember I'm using x values, and I'm starting left to right. Okay, my x value here of negative infinity until I got to this x value right here. This x value is negative 3. My graph was increasing. Okay, so I will write that in red. I was increasing until I got to there. Now I start to decrease. So I'm decreasing, and then I get to this x value, and now I start increasing again. So I'm increasing forever. So from this x value of 1 to infinity, my graph is increasing that entire range. It'll never stop increasing once I start on that path. Okay, so now we can switch over here and we can talk about decreasing. So decreasing happens, if I start on my graph again, I was increasing, I get to here, and then, now I'm decreasing. So I'm decreasing this whole way between those two x values. So from an x value of negative 3 to an x value of, right here at 1, my value of my function was decreasing. It was getting smaller and smaller and smaller. Okay, and then I hit this point and it turned around and it started increasing again. So those are some key features of graphs that we can look at, and let me know what questions you have.